Hello everyone, myself Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to solve question bank module 5, that means AC machines. In that part A, problem solving and critical thinking questions. In that total 10 questions. First question, a 4-pole 50H wound rotor induction motor has a rotor resistance 0.56 per phase and runs at 1430 rpm at full load, and calculate the additional resistance per phase to be inserted in the rotor circuit to lower speed to 1200 rpm if the torque remains constant. If the torque remains constant means torque is directly proportional to the slip and R2. Torque is depending on slip and rotor resistance. So we know this formula, torque and slip. Next, induced EMF in the rotor circuit, that relation S into E2 square into R2, that proportional. Now here solution for this. First, in this the R2 by S equals to R2 plus, here this is the inserted in the rotor circuit. This is the wound rotor. So there are two types of induction motor depending on the rotor circuit, depending on the rotor type. If it is wound, this another name is slip ring and squirrel cage induction motor and slip ring. If it is slip ring means slip ring, another name is wound rotor. So wound rotor resistance, we can change this resistance value. Squirrel cage induction rotor resistance we cannot change, that is fixed here. So here that inserted, if you insert some resistance, there may be a change rotor speed. So R2 by S. So R2 by at this first initial stage 0.56 ohm 56 resistance, and at that condition slip, and after slip means that's at 14. This slip is at 1430. And after that, if you insert some resistance in series with the rotor circuit, so at that case this is slip is 1200, slip 1 and slip 2. Now here, if you solve this, how you will calculate the slip value? To calculate the slip value, we need synchronous speed first. So what is the synchronous speed formula? 120 F by P here. So here 120 F by P means here the frequency value F equals to 50 Hz here, and number of poles are here 4. So frequency and poles, the synchronous speed of the induction motor is the 1500 rpm. So from the synchronous speed and this running speed, rotor speed, is we can determine the slip value. This slip at 1430. So now here slip is 1500 rpm and running speed is 1430 and 1500. This is slip at 1430 rpm. Slip at 14, that value is 0.0466. And next thing, slip at 1200 rpm. Slip at 1200 rpm means this is 1500, synchronous speed is fixed, and this, if you insert some resistance in series with the rotor circuit of the induction motor, that is slip ring induction motor, wound rotor induction motor. So at that case, that slip value is 0.02. This is 0.046. Now here the actual resistance is 0.056. Now here from this we can determine this is 0.046 and this one is 0.02 and this one is 0.056 and 0.056. So not 056, only 56, and from this we can determine the resistance value. So here R2 plus R equals to R2 by S into S2. This is slip at 1200 rpm and this is slip at 1430, and from this we can determine this one R equals to 1.87, this one. So in this way we can determine the inserted resistance value in series with the rotor circuit. Now coming to the second problem. So in the second, two 50Hz three-phase induction motors having 6 and 4 poles, 6 pole. So and next respectively are cumulatively cascaded. The 6 pole motor being connected with this is the 6 pole. This one is the main supply, and determine the frequencies of rotor currents and slip referred to the each stator field if the set has a slip of 2%. Now here first the given data. So here two induction motors, induction motor 1 and induction motor 2, they are connected cascaded connection. Now this is for 6 and this is 6 pole and this one is a for 4 pole. Now here, so actual complete synchronous speed for this combination of these two, here 120 F by P actual formula. So combination of these two synchronous machines indicates a 6 plus 4. So 120 and frequency is 50 Hz, and so first induction motor is the 6 poles and second induction motor having 4 poles, total 10, and 120 F by P, 6 plus 4, that value is 600 RPM. Now here from this we can determine this slip value is 2%. 2% means 0. That slip value is 0.02. This is 2%. Now, and we know this synchronous speed 600 RPM, and running speed of this entire set, this set is 588. If you substitute that NR equals to 1 minus S into S equal to this, this is the formula already we discussed. S equals to NS minus NR divided by NS. From this formula 588. Now here determine the frequency of the rotor currents. So rotor currents and slips means first determine the synchronous speed of individual. This is a complete set of synchronous speed individual. First 6 pole induction motor. This is a 6 pole induction motor, that is NS1 120 F by P, that is 1000 RPM. And in this, from this determine the slip value first. Slip value, this is not NS, S slip value. Slip value equals to slip value into 100. This one 1000. This 1000 is the this 1000. This one I am considering this one only 1000 minus 588. Running speed is the 588 divided by 1000 into 100. So now the percentage slip value equals to 41.2. Now here the percentage slips. This one first 6 pole induction motor slip value is 41 percentage slip value is 41.2, and if it is slip value is 0.41. Now here next the rotor frequency of 6 pole induction motor is, so if we know this formula, F for rotor frequency equals to slip into frequency value. Now this rotor frequency equals to this one 0.0412, this one, and 50 Hz is the supply. Total combination of these two is a 50 Hz supply. Now here that value equals to 20.665 Hz. Now second induction motor is 4 pole induction motor. For that case also same thing. So 120 F by P. So here 120 F by P indicates, now here frequency value is 21, this one. So now this one and this 4 is equals to next 630 this one. Here the 20.65. This value is 630. Now 630 RPM. Now here second case, here NS minus this 630 slip value, this is percentage slip value equals to 630, not percentage slip 630 minus 588 divided by 630. This is the running speed, and this is the 4-pole in 4-pole induction motor synchronous speed, and for this case 6.66 is the slip value. Now percentage slip value, this one, this is into percentage into 100 means that is percentage slip value. And next one is the rotor frequency of 4-pole induction motor is the FR equals to 0.066 into 21. 21 means 20.66 equals to 13.86 is the 13.86 is the 13.86 is the 4-pole induction motor frequency, rotor frequency. Now third problem, a 3-phase 6-pole 50 Hz induction motor when fully loaded runs with a slip of 3% and find the value of resistance necessary in series per phase of the rotor to reduce the speed by 10%, and assume the resistance of the rotor per phase is 0.2 ohms. Now here in this case, so first slip at 3%, percentage slip is here 3%, and 120 up by synchronous speed we know, if synchronous speed we can calculate from the 120 up by P, and there is a slip, and from this you can determine the running speed. So running speed, and this is 10% reduced speed. So we have two speeds and two slips, and we can determine, we know already this formula. So R2 by S equals to R2 capital R2 by R2 plus R by S2. So we know this relation. So torque is, when torque is constant, next torque is constant means torque is directly proportional to the S into R. So S R2 by rotor resistance divided first rotor at 3% slip. Next is when some resistance inserted in the rotor circuit at that case. So this R2 plus R. So we first calculate synchronous speed first. Ns equals to 120 F by P. So here frequency 50 and total 6. That is 1000 RPM. Here Ns equals to, next slip equals to, what is the slip value here? 1000, and here 1000 is a synchronous speed, and slip value is 3%, they have mentioned, and running speed equals to 1 minus S into Ns. This is the formula for running speed. So here that value equals to, slip equals 0.03 and 1 minus, this is the 1000. So that that running speed is the 970. And when we insert some resistance in series with rotor circuit, this is wound rotor, slip ring rotor, then only we can insert the resistance in series with the rotor circuit. Now in this case, so 10% speed is reduced. So 970 out of 970, 10% means 970 minus 970, that is 873. 970 minus 10% reduced by reduced. So at that case, so now here we know this formula. So now at that case, slip value, that reduced speed slip value 1000 minus 873 divided by 0.127. Now in this case, so we know this formula R2 by S equals to, this is at 970 slip, and this is at 873, reduced by speed reduced by 10 percentage. So 970 reduced 10 percentage means that is 873. Now here R2 plus R equals to R2 by S into S2. Now here, so this is the given this 0.2 ohms is the R2 value, and this one, and S is the this one slip value, this one is percentage slip 0.03, and next this one 0.127, this one 0.127 is the this one, and this one is the R2. So here the resistance value is the this one 0.646 ohms. Now in the fourth problem, a 4-pole 3-phase star connected alternator armature has 12 slots and 24 conductor per slot. The flux per pole is 0.1 Webers, and calculate the line EMF generated at 50 Hz, and calculate the distribution factor of 36 slots 4-pole single layer winding of alternator. Now here in this, actually the generated EMF formula here 4.44 into KD distribution factor and KC. This is not KD, KC, and coil span factor, and here F is the frequency and F phi is the flux per pole, and next one is the number of turns per phase. So now let us see the individual terms here. KD equals to sine m beta by 2, m divided by m sine beta by 2. Now here, so how the beta equals to 60 and m equals to 1. Now here m equals to m slots per pole per phase. How many number of poles here? Number of poles are here. Not, don't consider this one. Here first calculate. Number of slots are 12 and number of poles are 4 and number of phases are 6. Number of slots for pole for phase indicates 12 by 4 by 3 is the 1. Here m value equals to 1. This one m value. Now what about beta value? Beta equals to here 180 by n. Here beta equals to 180 by n equals to here 180 by n equals to here 180 as it is n. N equals to 3. How we got n value? N equals to slots per pole. So how many number of slots here? Total 12 slots and 4 poles. So 12 slots and 4 poles, and this is 3. So n equals to 3 value. Now if you substitute this 3 in this, you will get beta, and beta equals to 60, and this one is the 60. So now here the distribution factor KD equals to 1. Sine 60 by 2 means that is sine 30, and sine 60 by 2 sine 30. That value equals to 1. After getting KD, next KC value. KC value equals formula cos alpha by 2. Cos alpha by 2 equals to here alpha equals to 180 by n, same value. So 180 by 3 and divided by 2. This value equals cos 30 equals to 0.866, and we have this KD equals to 1 and KC equals 0.0866, and F equals to 50 and flux equals 0.1. What about turns? Number of turns equals to, now here 12 into 24 by next number of poles. Now this equals to this number of phase for phase. So T phase, that equals 3 into 4, that equals to 96. Now substitute all the values in this. Now here this is 96, 12 into 24 by 9 equals to 96. Here 4.44, and this is the KC and this one is the KD. KC and KD frequency. This is the flux and this one is the T phase. So this value equals to induced line EMF generated at 50 Hz, this one volts. Now here another question, second question, distribution factor of 36 slots 4 pole single layer winding of alternator. So here 36 slots means only the difference, here 12 slots and 36 slots. So see that case here. So same thing, 36, n equals to 36 slots per pole, and that equals to 9, and beta equals to 180 by 9, 180 by 9. So beta equals to 20. In the previous case, beta equals to 60. Now, m equals to number of slots per pole for phase. In the previous case, that one is 1, and 36 by 4, 36 number of slots, 36, and this is the 4 number of poles, and frequency phases are 3. So this value is 3. Now we know this formula, KD equals to sine m beta by 2 and divided by m sine beta by 2. Here m equals to 3. Next, beta equals to 20, and for this case the KD value is equal to 0.959. Next, fifth question. A part of an alternator winding consists of 6 coils in series, each coil having an EMF of 10 volts RMS induced in it. The coils are placed in successive slots between each slot and the next there is a electrical phase displacement of 30 degrees. Calculate the EMF of 6 coils in the series. Solution for this. So given data here, this beta equals to 30 degrees, and m equals to 6. Total number of coils 6. And next, KD equals to displacement distribution factor equals to sine m beta by 2, m equals to sine beta by 2, and sine of 60 into here m equals to 6 and beta equals to 30. So sine of 6 into 30 divided by 2 and by 6 into sine 30 by 2, that value equals to 0.643. Now here the arithmetic sum of voltages induced in 6 coils. So total this one 10 into 6, that equals to 60 volt. Now vector sum equals to KD. KD value is this one and arithmetic sum is this one. So total 60. And now the vector summation equals to 0.643 into 60 equals to 38.64 volts. Now here next one, sixth problem. Next, induction motor problems all are. Now in case of an 8-pole induction motor, the supply frequency was 50 Hz and the shaft speed was 735 rpm. Compute the synchronous speed, slip speed per unit slip and percentage slip. So here synchronous speed equals to 120 f by p, this one, and this slip speed equals to ns minus nr divided by ns, and this percentage slip equals to ns minus nr divided by ns into r into 100. Here slip speed indicates ns minus, for this if they ask this one, ns minus nr only. Slip speed per unit slip indicates ns minus nr divided by ns. Here total same terms, percentage slip indicates ns minus nr by 100 and slip speed only indicates ns minus r, and slip speed per unit slip is ns minus nr divided by ns, and synchronous speed is ns equals to 120 f by p. Now here, so frequency value is 50 Hz and number of poles are 8, frequency is 50 Hz and 120 f by 50 and 8, that is 750 rpm. And next one, this is the slip speed per unit slip is the 0.02, 750 this one, and 735 is the running speed, this one, and from this 0.02. Next, percentage slip is into 100, so 750 minus 735 divided by 750 into 100, that equals to 2%, 2% slip. Next, seventh question. A 6-pole 50 Hz squirrel cage induction motor runs on load at a shaft speed of 970 rpm. Next, calculate percentage slip, the frequency of induced current in the rotor. So now here, what about percentage slip? Percentage slip, to get the percentage slip, we need running speed and this one, running speed NR, and next one, this one is the one NS. Now here the given data F equals to 50 Hz and P equals to 6, and only this data is sufficient, and NR equals to 970. Now here NS equals to 120 F by P. So P equals to 6, NS equals to 50, and this is equal to 1000 RPM. Now we got synchronous speed value. Synchronous speed value equals to 1000 RPM. This is the running speed. If we know the running speed and synchronous speed, we can determine the percentage slip. Percentage slip formula, NS minus NR divided by S into 100. So 1000 minus 970 divided by 1000 into 100 here. So into 100 means, that means percentage slip. And this if NS minus NR by only NS minus NR by NS means, that is slip speed per unit slip. So next NS minus NR indicates that is slip speed. So here this, in this case, 3% only. Now here we have 3%, percentage slip is 3%. Now from this slip and this frequency, so stator frequency equals to 50 Hz. We have the stator frequency and we have the percentage slip. So that value, now we can determine the rotor current frequency, not rotor current. Here frequency, in the question they are asking the frequency value, not current value. So that rotor current frequency equals to FR equals to S into F, that equals to, this is a 3%, 0.03, and this one is a 50 Hz, that equals to 1.5 Hz. This one, 1.5 Hz. Now here 7th question. Okay, next 8th one. In case of 6-pole induction motor, the supply frequency was 50 Hz. The shaft speed was 925 RPM. Same formula, same thing, only numerical changed. Okay, now compute the, determine synchronous speed. Same thing, already we calculated this one, 120 F by P, 120 into 50 divided by 60. That one is synchronous speed. And this one, slip speed. Slip speed means NS minus NR, and slip speed per unit slip is the NS minus NR divided by NS, and percentage slip is the NS minus NR divided by NS into 100. Now moving on to the solution. Here 120 F by P, that equals to 120 into 50 divided by 6. This is the frequency and these are the number of poles, and this one is the RPM, 1000 RPM. Next, per slip speed per unit slip equals to this formula, this one. Here this is 925, this one, and 1000 is the synchronous speed, and here for this case 0.075. So for percentage slip, so this one into 100. So multiply this one 100, you will get the percentage slip. So from this you can determine that rotor current frequency also, multiply with this percentage, this slip into this frequency, then you will get the rotor frequency also. Next question, 9th question. In case of an 6-pole induction motor, the supply frequency was 50 Hz and the shaft speed was 970 RPM. Compute the synchronous speed and percentage slip. Similar type of problems. So given data, same 120 F by P. So this one 50 is a 50 Hz and 6 poles. Next, RPM, 1000 RPM. Next 970 RPM is the NR. So from this you can determine this is the synchronous speed. 120 F by P, 120 into 50 by 6 is equal to 1000 RPM. Now here percentage slip equals to NS minus NR into 100. Now here 1000 and 970 and this one is the 1000 and this is the 100. Now percentage slip equals to 3%. 970 is the running speed NR. Now 10th one. A 3-phase 6-pole induction motor is supplied from the 50H 440 volt supply. Calculate the synchronous speed and speed of the rotor when slip is 4%. So now here same thing, 120 F by P, 1000 RPM. This is the frequency and this one is the number of poles, 50H. And next synchronous speed is 1000 RPM, this one. Next speed of the rotor, so NS minus NR divided by NS equals to slip. This equals to, so from this you can write this formula, NR equals to 1 minus S into, this formula is important, 1 minus S into NS, that equals to, here slip value is 4%, 0.04. This is the slip S value and this synchronous speed is the 1000. Here the value of running speed, the speed of the rotor when slip is 4% is the 960. NR equals to, now NR equals to. Now here the important formulas in this 5th module, alternator and induction motor. So first in the induction motor I am writing, so first important formula is 120 F by P, synchronous speed equals to 120 F by P. F is the frequency of supply and P is the number of poles. And next thing, slip equals to NS minus NR. This is slip speed. And slip speed per unit slip is equal to NS minus NR divided by NS. Next, percentage slip equals to NS minus NR divided by NS into 100. So next, rotor current frequency equals to FR equals to S into F. So these are the most important formulas in the 5th module, induction motor. And after that resistance inserted R2 plus R divided by S2 is equal to R2 divided by S. So this formula is also important. Next, in the alternator case, next in the, this is in the induction motor. In the alternator case, AC generator case, now here the induced EMF equals to 4.44 F into 5 into number of turns per phase and KD into KC. This is the most important, and here KD equals to M into sine of beta into M, sorry not M, sine of M beta by divided by 2 and M into sine beta by 2, and here M equals to number of slots per pole per phase and slots per pole per phase, and beta equals to 180 by N. Here N equals to slots per pole, and same way Kc equals to cos alpha by 2, not this one, cos alpha by 2. Here alpha equals to 180 by 2. So now here these are the important formulas in the 5th module. So I hope all the 10 problems are clear to you. If you still have any doubts, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.